Welcome, curious minds, to another deep dive. Have you ever paused to consider the monumental effort behind a new healthcare IT system, like the electronic health record your doctor uses? It's far more than just installing software. It's really an intricate ballet of technology, people, and processes that literally underpins modern patient care. Today, we're embarking on a deep dive into this incredibly complex world. The rigorous process of selecting, implementing, and then continuously maintaining these vital healthcare information systems. It's a massive undertaking.
It really is. And what's truly fascinating, I think, is how this entire process, from identifying a specific organizational need right through the ongoing support and evolution of a system, forms the absolute backbone of efficient, high-quality patient care. Our mission today is to cut through some of that complexity, maybe provide you with a clearer roadmap of this whole journey. Because a truly successful system isn't just about the cutting-edge technology. It's profoundly about organized processes, seamless integration, and crucially, people. Getting those aligned is key.
Absolutely. And to guide us through this intricate journey, we've drawn insights from a comprehensive guide on healthcare system management. So, prepare for some surprising facts and hopefully some practical insights into how these colossal projects are actually managed. You might just see your next doctor's visit or even, your local hospital in a whole new light after this. So let's kick off with the very first and maybe the most critical major phase, selection. This isn't a quick decision, is it? Not like picking something off a shelf.
Oh, not at all. It really begins much earlier, with a clearly identified organizational need. Often this comes from maybe a problem that's blocking the organization from achieving a strategic objective. It's not just, we need a new system, it's we need to solve this problem.
Right, there's a why behind it.
Exactly. And that why gets formalized into a project proposal. This isn't just a casual idea. It's the foundational step that sets the stage for, well, everything that follows. Get this wrong, and the whole project can go off track.
Okay, so the need is identified, the proposal is written, who decides if it actually goes forward?
That's where the governance committee comes in. And, they aren't just a rubber stamp. They act as the organization's strategic compass, really.
So they're the gatekeepers.
In a strategic sense, yes. They rigorously evaluate that need against the organization's overall mission, its strategic goals, the existing IT strategic plan, which is vital, and, of course, the budget and available resources. This initial alignment is absolutely crucial. It ensures that what could be a multi-million-dollar IT investment directly steers the organization toward its most critical objectives.
So it prevents pet projects or like buying tech just for tech's sake?
Precisely. It avoids those costly detours into fixing isolated problems that don't really move the needle on the bigger strategic picture. It forces that discipline right at the start.
Okay, makes sense. So the governance committee gives the green light. The project is a go. Now you need a system. How do they start looking?
Right. Now the organization moves into vetting potential vendors. And this brings us to two cornerstone tools, two acronyms you often hear. The RFI, which is the request for information, and the RFP, the request for proposal.
Okay, RFI and RFP. A lot of people know these terms, maybe from other industries too, but what's often misunderstood, maybe, about how healthcare organizations strategically use an RFI versus an RFP, is there a common mistake people make?
That's a great question, because their strategic deployment really can set a successful vendor selection apart from one that, well, struggles. Think of the RFI as an initial exploratory conversation, almost like market research.
Like window shopping.
Kind of, yeah. It's an informal document used to gather general information from a wide range of prospective vendors. It helps an organization cast a wide net, understand the landscape of capabilities, see what broad solutions are out there, all without any real commitment. An RFI might not even include detailed budget information at this point. It's purely for discovery. You might send it to, say, 15 or 20 vendors just to see who responds and what the realm of possibilities looks like.
So low stakes, broad reach.
Exactly. But the RFP, the request for proposal, that's a different beast altogether. It's a far more formal, much more detailed document. It outlines precise, sometimes incredibly granular requirements based on that initial needs analysis. It also specifies exactly how each responding vendor will be evaluated and compare the criteria for the final decision are laid out. And crucially, an RFP always includes timelines and detailed budget or cost information requirements.
So the money question is definitely in the RFP.
Definitely. An RFP is explicitly designed to lead directly to a contract negotiation. Setting one out signals serious intent. It forces the organization and the vendors to get specific. It basically asks the market, are you just exploring options, or are you truly ready to commit and begin the formal procurement process?
Got it. So RFI is what's out there. RFP is who can deliver exactly this for this price by this date.
That's a good way to put it.
Okay, so those RFPs go out, proposals start pouring back in, presumably thick documents filled with technical details and promises. That sounds overwhelming. How do organizations even begin to sift through that mountain of information and really narrow down the choices? It can't just be about price.
No, definitely not just price, although that's always a factor. It's a multifaceted evaluation process.
Yeah.
There are several key vendor evaluation activities. One really important one is on-site visits.
Going to see the system in action somewhere else?
Exactly. The selection team goes to another hospital or clinic that's already using the system. They see it operating in a real healthcare environment, talk to the users there, doctors, nurses, administrators, and get a feel for how it actually works day to day. It's invaluable.
I can imagine. You get the unvarnished truth, maybe.
Hopefully. That's also where reference checks come in. Speaking directly, maybe formally, with existing clients listed by the vendor, but also sometimes trying to find other clients independently for, let's say, more candid feedback.
Good point. What else?
Demonstrations are obviously vital. The vendors come in and showcase their product.
Yeah.
But here's a critical tip for organizations. Don't just let the vendor run their standard demo,
Why not?
because they'll only show you the polished, best-case scenarios, right? Smart organizations provide vendors with a list of specific scenarios or workflows beforehand, tailored to their own needs. Maybe it's, show us how a doctor orders this complex medication regimen, or demonstrate the workflow for registering a patient with this specific insurance.
So you force them to show you how it handles your specific challenges.
Precisely. It ensures comparability across all vendor demonstrations, rather than just seeing generic features that might look flashy but don't address the core requirements.
That's clever. Anything else in the evaluation toolkit?
Yes, especially with the rise of cloud solutions, trial versions or sandbox environments are increasingly common. These allow key users to get hands-on experience, click around, test workflows, really kick the tires before making a commitment.
Like a test drive for software.
Exactly like a test drive. And finally, there are extensive background checks. This goes beyond just the product itself. Teams assess the vendor's financial stability. You don't want your critical software provider going bankrupt, right?
Definitely not.
They look at market share, read analyst reports, check customer satisfaction surveys, and assess the product's maturity. Is it brand new? Potentially buggy? Or is it a well-established system? This ties into the organization's risk tolerance. Do they want to be an early adopter of something cutting edge, or prefer a more tried-and-true solution? That choice significantly impacts the evaluation.
So it's a really thorough investigation of both the product and the company behind it.
It has to be. The stakes are too high.
So, okay, they're doing these visits, checks, demos. What specific criteria are they actually judging these systems against during all this? What are the absolute non-negotiables in a healthcare IT system?
The criteria generally fall into two main buckets. First, there are the functional requirements. This is about what the system actually does.
Like, can it handle medication orders?
Yeah.
Can it generate the reports we need?
Exactly. Specific clinical functionalities, billing capabilities, reporting tools, integration requirements with other existing systems, all the tasks the system needs to perform to meet that initial organizational need we talked about.
Okay, functional requirements. What's the second bucket?
That's the non-functional requirements. This isn't about what it does, but how it does it. Think technical aspects.
Like speed, reliability.
Yes, things like performance, scalability. Can it handle our patient volume now and in the future? What's the underlying infrastructure, especially if it's cloud-based? What are the disaster recovery capabilities? And absolutely paramount in healthcare, what are the security and privacy features? These are often deal breakers.
I bet. Security and privacy have to be top of the list.
Absolutely non-negotiable. But another critical consideration, often falling somewhere between functional and non-functional, is interoperability.
Making sure it plays nicely with others.
Precisely. The system's ability to seamlessly communicate and exchange data with other existing systems, the lab system, the radiology system, maybe systems at other hospitals or clinics, this is where technical standards become incredibly important.
Like those acronyms you hear sometimes, HL7.
Exactly. Standards like HL7 version 2, which has been a workhorse for decades, and the newer, more modern standard, FHIR, that stands for Fast Healthcare Interoperability Resources. Think of these standards as the healthcare industry's common language, or maybe it's Rosetta Stone.
Allowing different systems built by different companies to actually understand each other's data.
Yes. Without these standards, you just have data silos, and you can't get that complete patient picture. So robust support for standards like HL7 and FHIR is a critical evaluation point. And of course, underpinning everything is strict regulatory compliance. The system has to meet all government mandates, security protocols like APN in the US, and specific privacy laws.
That's a lot to evaluate. And are they always just choosing between vendor products, or do some organizations consider building their own?
That's another crucial decision point. The build versus buy analysis. Do they have the internal expertise, the time, and the budget to develop a custom solution in-house? Or does it make more sense to purchase an off-the-shelf product from a vendor and configure it? There are pros and cons to both. Building gives you ultimate customization, but can be slow, expensive, and requires long-term maintenance commitment. Buying is often faster and leverages vendor expertise, but you might have to adapt your workflows to the software to some extent. The decision really hinges on the organization's specific circumstances, their in-house skill sets, budget constraints, required timeline, and overall IT strategy.
And related to that, I suppose, is the cloud question.
Yes. The cloud versus on-premise analysis is almost always part of the discussion now. Do we want the vendor to host the software in their data centers, cloud SaaS, or do we want to install and manage it on our own servers, on-premise? Again, trade-offs. Cloud often means lower upfront hardware costs, easier scalability and automatic updates, but might involve recurring subscription fees and raises questions about data control and security oversight. On-premise gives you more direct control, but requires significant investment in hardware, infrastructure, and personnel for maintenance, security, and upgrades.
So factors like personnel needs, hardware budgets, monitoring capabilities, auditing requirements, and especially how privacy and security are handled in each model, they all feed into this decision.
Correct. It has to align with the organization's overall IT infrastructure strategy and risk appetite.
Wow. It certainly sounds like a decision requiring a lot of different viewpoints and expertise. Who typically makes up this crucial selection review team to ensure all these different angles, technical, clinical, financial, strategic, are thoroughly considered?
You're absolutely right. Getting the right people involved is absolutely key to making a sound decision. A core selection review team is usually assembled specifically for this purpose.
So who's at the table?
Typically, it's led by a facilitator, someone skilled in managing group dynamics and keeping the process on track, often from the project management office. Then you absolutely need an executive sponsor.
A champion from the top.
Exactly. Someone senior who champions the initiative, secures resources, and helps overcome organizational hurdles. Their visible support is critical. Then you have the technical folks, technical representative providing expertise on IT infrastructure, maybe biomedical engineering if devices are involved, or telecom expertise.
Makes sense. Who represents the people actually using the system?
That's arguably one of the most crucial roles. The business representatives. These are the clinical end users, doctors, nurses, therapists, registrars, billers. They are highly knowledgeable about the current workflows, the pain points, and what the new system must do to make their life easier and improve patient care. Their input is non-negotiable.
I can see why, if they don't like it or can't use it effectively.
The project fails.
Yeah.
Simple as that. You also need a project manager, bringing methodology expertise, planning skills, risk management. A contracting representative is essential for the legal and negotiation side of things. A financial representative keeps an eye on the budget, ROI calculations, and payment terms.
Okay, that covers tech, users, management, contracts, money, anyone else.
Yes, increasingly, organizations include an organizational change leader, someone with expertise in the human side of change, communication strategies, training approaches, and addressing resistance. Because implementing a new system is as much about changing behaviors as it is about technology.
That seems really smart. Getting all those voices, executive, technical, clinical, financial, project management, legal, change management around the table from the start ensures all the different facets of this complex decision are considered.
It's the only way to make a truly informed choice that the entire organization can get behind.
Okay, so the stream team is assembled. They've done the RFPs, the demos, the site visits, the reference checks. They've debated build versus buy, cloud versus on-prem. They've narrowed it down to maybe 2 or 3 strong contenders. What happens next to get to the final choice?
Now it moves into the final dance of negotiation and final selection. With those few strong contenders remaining, the contracting representative, working closely with the financial and technical reps, leads the negotiations.
Hammering out the details.
Exactly. Negotiating the best possible price, refining payment plans, finalizing the scope of services, clarifying support level agreements, SLAs, sorting out implementation assistance, data conversion costs, all the fine print. This can be quite an intense back and forth.
I bet. And once the best and final offers are on the table.
The selection review team makes the final decision based on all the evaluation criteria, the demo scores, the site visit feedback, the reference checks, and of course the negotiated terms. And here's something absolutely crucial. The entire process, from the initial needs assessment through every evaluation step, the scoring, the negotiations, and the final justification for the chosen vendor must be meticulously documented.
Why is that documentation so critical? Just for internal records?
Partly, but it's also vital if, say, an unsuccessful vendor decides to contest the award. Having that clear, objective, documented trail showing a fair and thorough process is essential legal protection. It also serves as a baseline for measuring the project's success later on.
That makes sense. Protects the organization and provides accountability.
Precisely. And it's also during this final phase that the comprehensive budget development gets finalized. This isn't just the vendor's software cost or subscription fee.
Right. There's more to it than just the sticker price.
Much more. It has to include costs for internal staffing, project managers, trainers, analysts. It includes the cost of end-user training time, potentially backfilling their positions while they train. It includes any necessary hardware upgrades, servers, networks, workstations, maybe mobile devices, integration services to connect the new system to existing ones, data conversion costs, contingency funds for unexpected issues. It's a total cost of ownership picture.
Wow. That sounds like a significant effort just to finalize the budget properly.
It is, but getting that realistic, comprehensive budget approved before signing the contract is fundamental to project success.
Okay, so after all that intense scrutiny, negotiation, and budgeting, the contract is signed, the system is officially chosen, the strategic thinking ends, maybe, and the real marathon begins.
You could say that. The what is decided, now it's all about the how. We're now moving from selection into phase 2, implementation. This is where the digital blueprints truly start coming to life.
And you hear horror stories about IT projects going sideways during implementation. It's often said, I think you mentioned it earlier, that the majority of IT project failures aren't actually due to bad technology itself, but more to inadequate planning or poor execution during implementation. Does that hold true for these big, complex healthcare implementations?
Absolutely. Overwhelmingly so. The vast majority of project failures, cost overruns, and missed deadlines can be traced directly back to inadequate or poorly executed planning during the implementation phase. The technology might be perfectly fine, but if the rollout isn't managed well, it's doomed.
So planning is paramount. What does that look like? What are the typical stages within implementation?
A successful implementation generally follows a set of standard phases. While the names might vary slightly between methodologies, you typically see something like planning, analysis, design, build, test, train, implementation, or go live, and finally, close out.
Okay, quite a few steps there.
Yes, and the very first step, flowing directly from the selection phase, is creating a really comprehensive project management plan. This isn't just a timeline.
What goes into it?
It defines the detailed project scope, what's in, what's out. It outlines the governance structure for the project itself. It includes risk management planning, identifying potential problems, and how to mitigate them. A crucial change management plan, how modifications during the project will be handled. Detailed plans for training, testing, communication, issue tracking, resource allocation. It's the master blueprint for the entire implementation effort.
Sounds exhaustive.
It needs to be. And once that plan is drafted and approved, it's formally communicated to all stakeholders, the project team, the executives, department heads, key end users, during a formal kickoff meeting. This gets everyone on the same page, clarifies roles and expectations, and officially launches the implementation phase. It sets the stage for the enormous amount of work ahead.
You mentioned change management being a specific part of that plan. We often focus on the tech, the software, the hardware, but you hinted earlier that the real challenge is often the people side. How significant is the human element in successful implementation, and how do organizations even begin to tackle that massive challenge of changing how people work?
It's huge. I'd argue it's often more critical than the technology itself. You can have the best system in the world, but if users don't adopt it, if workflows aren't redesigned effectively, if people resist the change, the project will fail to deliver its intended value.
So the goal isn't just to automate what they were doing before.
Ideally, no. New systems shouldn't just pave the cow paths, as they say. They should be an opportunity to fundamentally improve processes, make them safer, more efficient, more patient-centered. Effective change management is what enables that transformation.
How does that work in practice? What does good change management look like?
Well, first, it requires that unwavering top-level support we talked about from the executive sponsor. Their consistent messaging about the why is crucial. Second, it demands robust stakeholder involvement, especially from the end users.
Getting them involved in the design.
Yes, actively participating in workflow redesign sessions. They know the current process best, its flaws, and how the new system could help. Involving them in selecting hardware like workstations on wheels, barcode scanners, tablets also increases buy-in. If the tools fit their physical workflow, they're more likely to use them. The change management team also needs to proactively identify potential sources of resistance. Why might people push back? Fear of the unknown, loss of familiar routines, concerns about job security, perceived increase in workload.
All sounds plausible.
They are. So the team develops strategies to address these concerns, directly clear communication, targeted training, highlighting the benefits, though what's in it for me, creating user champions or super users within departments, and providing ample support during the transition.
So it's really about understanding the psychology of change within the organization.
Absolutely. Adoption is often directly correlated with the end user's perceived benefit of the system and how well it truly fits into and ideally enhances their daily workflow. If it feels clunky, adds extra clicks, or seems to slow them down even if it offers other benefits, adoption will inevitably suffer. It has to make their job easier or demonstrably improve patient care for them to embrace it.
Okay, that makes a lot of sense. Focus on the user experience and the perceived value. So the plan is set, change management is underway.
Yeah.
How do organizations actually go live? You mentioned different strategies earlier. What are the strategic implications of the various ways they can roll out a system of this magnitude?
Right. The implementation strategy is another key decision made during the planning phase. There are several common approaches, and the best choice really depends on the organization's culture, its tolerance for disruption, the nature of the system being implemented, and the project objectives.
What's the most dramatic one?
That would probably be the Big Bang approach.
Mm-hmm.
This means going live with all the new functionality across all departments or locations simultaneously, usually over a specific weekend or holiday period.
Wow. All at once. Sounds risky.
It is high risk, yes.
Yeah.
It requires incredibly detailed planning and coordination. If something goes wrong, it affects everyone, everywhere, immediately. However, it's often used when replacing an entire legacy system where running old and new in parallel isn't feasible. The main advantage is that the project duration is typically shorter and everyone transitions together.
Okay, Big Bang. What are the alternatives if that sounds too scary?
A very common alternative is a phased approach. This can be done in a couple of ways. Phased by location means you bring all the functionality live, but only in one hospital or one clinic or maybe one nursing unit at a time.
So you pilot it somewhere first.
Essentially, yes. You roll it out sequentially across different sites. This extends the overall project duration, obviously, but it allows the team to learn lessons, refine the process, and make improvements before moving to the next location. It contains a risk to a smaller area initially.
Sounds more manageable. What's the other phased approach?
Phased by functionality or phased by module. Here, you roll out one piece of the system's functionality, maybe the registration module first, then the clinical documentation module, then order entry across all locations. This allows users to adapt to the changes more gradually, learning one new set of functions at a time. The challenge here is that you often need temporary interfaces between the new modules and the remaining parts of the old system, which can add complexity.
Right, managing that hybrid environment.
Exactly. Another related strategy is a formal pilot implementation. This is similar to phase by location, but maybe even smaller scale, testing the system with a single small group or department first. It's purely a test run, so work out the kinks before committing to a broader rollout using one of the other strategies.
Okay, so Big Bang, phased by location, phased by functionality, pilot, any others?
One more worth mentioning is sometimes called parallel conversion, though that term can be ambiguous. The idea here is to replace the old system with the new system mimicking the old functionality as closely as possible first.
So not introducing new features or workflow changes right away.
Correct. You get the new technology platform in place, get users comfortable with the basic interface, and then you start rolling out the new improved features and workflows in subsequent phases. This decreases the complexity and change shock of the initial go live. The downside is that users might not immediately see the benefits, asking, why did we go through all this trouble for something that just does what the old system did?
Managing expectations there is key.
Very key. So the choice of strategy really depends on balancing risk, speed, resources, user readiness, and the specific system's characteristics.
Now, let's talk about the actual build phase you mentioned in the implementation stages. This isn't just flipping switches on the software the vendor delivered, is it? How is that initial, maybe vanilla application actually tailored to fit the organization's specific needs and workflows?
No, flipping switches doesn't quite capture it. The build phase, which often overlaps with design and analysis, is where the vendor's base application is extensively customized and configured. This is intricate, detailed work.
What kind of things are getting configured?
Almost everything, really. Think about clinical documentation. Every template, every flow sheet, every assessment form needs to be built or configured to match the hospital standards and practices. Think about order entry. Every single medication, every lab test, every radiology exam, every dietary order, every consult request needs to be built into the system with its specific parameters, potential interactions, and associated workflows.
Wow, every single order.
Every single one. Patient demographics, configuring all the fields, drop-down lists for insurance types, race, ethnicity, all according to reporting requirements. Security settings defining user roles and exactly what each role can see and do within the system. Decision support rules, building alerts for drug interactions, reminders for required documentation, clinical guidelines. The list is enormous.
It sounds like thousands, maybe tens of thousands, of detailed configuration points.
Easily. It requires deep collaboration between the IT build team and the clinical or business subject matter experts to ensure the system is configured to support safe, efficient, and compliant workflows.
And what about the data from the old system? Does that just get left behind?
Yeah, absolutely not. That's another critical part of the build phase. Data conversion and migration. You have to bring relevant patient information, historical data, and sometimes system configuration data over from the legacy system into the new one.
That sounds technically challenging.
It is. Immensely so. Imagine the nightmare scenario. Patient allergies don't migrate correctly, leading to a dangerous medication order. Or critical historical lab results get mismapped or lost. That's why data conversion isn't just a technical file transfer, it's a meticulous, high-stakes operation. It requires careful planning what data needs to come across, how far back. It involves mapping fields from the old system to the new one, cleaning the data to remove errors or inconsistencies, performing test conversions, and extensive data validation post-conversion to ensure accuracy and completeness. Preventing duplicate patient records is often a major challenge here too.
So validation is key to ensuring patient safety isn't compromised during the switch.
Absolutely critical. And a vital part of both configuration and data conversion is vocabulary mapping. This involves ensuring that the terms used within the new system align with required industry standards.
Like those standards you mentioned earlier.
Exactly. Mapping internal medication names to RX norm, the standard for clinical drugs. Mapping local lab test names to LOINC, the standard for laboratory and clinical observations. Mapping clinical problems or diagnoses to SUNMED-CT, the standard clinical terminology. The standardization is essential for interoperability, reporting, quality measurement, and research. It ensures everyone is speaking the same language electronically.
So the build phase is really about configuring the system and preparing the data, making sure it's accurate and standardized. That's a huge chunk of work.
It often is the longest and most resource-intensive phase of the implementation.
With all that complexity, all that detailed configuration, those intense workflow discussions, managing scope creep must be a constant battle. How do projects prevent those little, oh, can we just add this one more thing, requests from quietly spiraling out of control and derailing the timeline and budget?
You've hit on a major challenge in any large IT project, and healthcare is no exception. Scope creep can be insidious. Managing it effectively isn't just about process. It's about maintaining disciplined focus on the original objectives agreed upon back in the selection phase.
So how do they enforce that discipline?
Through that robust change management plan we mentioned as part of the overall project plan. This isn't the organizational change management piece, but rather the plan for handling in-project changes to the scope, schedule, or budget. This plan clearly defines who is allowed to submit a change request, what information must be included in the request, how will the request be logged and tracked. Crucially, how will each request be evaluated for its impact on the project, on the timeline, the budget, the resources needed, the potential risks, alignment with strategic goals.
So every requested change gets formally assessed.
Yes. And perhaps most importantly, the plan defines who has the authority to make the final decision on whether a change is approved, denied, or may be deferred until after the initial go live. This usually involves a change control board or committee, often including the project manager, executive sponsor, and key technical and business leads.
So it prevents random changes from slipping in without proper vetting?
Exactly. It forces a structured discussion about the costs and benefits of each proposed change. Without this formal process, even the most well-planned project can quietly transform into an over-budget, behind-schedule behemoth that delivers something different and often less valuable than originally intended.
Yeah.
It requires saying no sometimes, or
Yeah.
not now.
Discipline is key. Now, you mentioned integration earlier, connecting the new system to others. Healthcare environments are full of different systems: lab, radiology, pharmacy, billing, scheduling. How do they handle this system integration piece? How do all these different digital pieces connect and communicate effectively to ensure clinicians get that holistic patient view they need?
System integration is absolutely vital. Rarely does a major healthcare system like an EHR stand completely alone. It needs to exchange information constantly with numerous other specialized systems.
How does that data exchange actually happen?
There are several common integration types. Real-time integration involves near-simultaneous data sharing. A classic example is using those HL7 messages we talked about. When a doctor places a lab order in the EHR, an HL7 message is instantly sent to the Laboratory Information System, LIS. When the results are ready in the LIS, another HL7 message sends them back to the EHR to appear in the patient's chart.
So it feels seamless to the user?
Ideally, yes. Then there's scheduled integration, sometimes called batch integration. This involves transferring data between systems at predetermined times, maybe overnight. This might be used for things like sending billing information from the EHR to the financial system, where real-time updates aren't strictly necessary. And increasingly important is device integration. This involves getting data directly from medical devices like vital sign monitors, ventilators, infusion pumps into the EHR automatically. This reduces manual data entry errors and provides more timely information.
That sounds really useful, but also potentially complex to set up.
It can be. All these different integrations, managing potentially hundreds of data feeds between dozens of systems, are often facilitated by a specialized piece of middleware called an interface engine.
What does the interface engine do?
Think of it as a central traffic cop or translation hub for data exchange. It receives information, messages from one system, looks up where that information needs to go, and routes it to the appropriate destination systems. Crucially, the interface engine can also transform the data along the way. If the sending system uses a slightly different format or vocabulary than the receiving system, the interface engine can translate the message into the format the receiver understands, ensuring compatibility. It's a critical piece of the interoperability puzzle in most hospitals.
So it manages the connections and the translations between all these disparate systems.
Exactly. Building, testing, and maintaining these interfaces is a significant task within the implementation project and ongoing operations.
Okay, so the system's being built, configured, data migrated, interfaces developed. What about getting the staff ready? With all these complex new systems and redesigned workflows, training must be absolutely critical for success. What are the biggest challenges in getting hundreds or thousands of staff members ready and proficient, and how do organizations ensure that knowledge actually sticks?
Training is paramount. As we discussed with change management, user adoption is key, and effective training is the foundation for that adoption. You can't expect people to use a system well if they haven't been properly trained.
So how do they approach it? Just classroom lectures?
It's usually a blended approach. Organizations develop comprehensive user training programs tailored to different roles. Doctors will need different training than nurses, who need different training than schedulers. This often involves creating detailed training manuals or online learning modules. Setting up a dedicated training environment, a copy of the system specifically for practice, is essential. This allows users to get hands-on experience without fear of impacting real patient data. Classroom sessions led by instructors, often train-the-trainer approaches where internal staff become experts, are common. E-learning modules for self-paced learning are also widely used. Role-based competency testing is often required before users are granted access to the live system.
Sounds comprehensive. What are the main challenges?
One of the biggest challenges is timing. You want to train people close enough to the go-live date so the information is fresh, but you also need to get everyone through the training pipeline, which can take weeks or months for a large organization. Information degrades quickly if it's not used.
The use it or lose it problem.
Exactly. Another challenge is tailoring the training effectively to diverse learning styles and computer literacy levels. And simply scheduling the training, pulling busy clinicians away from patient care, is a huge logistical hurdle requiring significant planning and often temporary backfill staffing.
How do they support users right after go live when they're most likely to forget things or run into issues?
That immediate post-go-live period is critical. Experience shows there's almost always a need for just-in-time training and readily available support. This often takes the form of at-the-elbow support, having trainers or designated super users, staff members who received extra training, physically present on the units or in clinics to answer questions and help users navigate the system in real time as they work. Having a well-staffed help desk or command center is also crucial during this period.
So continuous reinforcement right when they need it most.
Yes, that immediate support can make or break the initial user experience and confidence.
Okay, so building, testing, data migration, interfaces, training, all these complex threads are starting to come together. This leads us to the climax of the implementation phase. Activation planning, or simply go live. This must be the big day, the culmination of months or even years of work. What goes into preparing for that pivotal moment when the switch is finally flipped?
It absolutely is the culmination of immense effort, and the pressure is definitely on. Successful activation requires incredibly detailed planning. Pre-go-live activities are meticulous. This involves creating detailed checklists, often hour by hour, sometimes minute by minute, outlining every single task that needs to be completed by specific teams or individuals before, during, and immediately after the system activation.
Leaving nothing to chance.
Try not to. This includes final data loads, technical configurations, security checks, and crucially, meticulous system downtime planning. If the old system needs to be taken offline before the new one comes up, that downtime needs to be carefully coordinated with clinical operations to minimize disruption to patient care.
What about practicing the cutover itself?
That's a critical step. Conducting rehearsals or dress rehearsals of the activation process. The core project team, technical teams, and sometimes key operational leaders will walk through the entire activation checklist, performing the actual steps, or simulating them in a test environment.
Like a dry run.
Exactly. These rehearsals are invaluable. They test the plan itself, uncover potential gaps or overlooked dependencies, identify and fix mistakes before the real event, and crucially, they build the project team's confidence. They've already executed the task successfully at least once, which reduces anxiety on the actual go-live night.
Smart. What about the logistics on the day itself?
Logistical considerations are paramount. This typically involves setting up a central command center, a physical location, where project leaders, technical support, vendor support, and key operational stakeholders gather during the activation and initial support period. This facilitates rapid communication and decision-making. Ensuring there's food and drink available is surprisingly important, as teams often work very long hours. Having clear communication plans, how updates are disseminated, how issues are reported, and well-defined issue escalation pathways, who gets called for what type of problem, and when, are absolutely essential for managing the controlled chaos of go live.
Controlled chaos. I like that. So the button is pushed, the system is live. What happens immediately after? Is it just smooth sailing, everyone high-fiving, or are there still critical considerations in those first few hours and days?
High fives hopefully happen eventually, but definitely not smooth sailing right away. Immediate post-activation support is crucial, as we touched on with training. The intensity and duration really depend on the system's impact and the implementation strategy used. For a new electronic health record going live via Big Bang in an acute care hospital, support staff, internal IT, trainers, super users, vendor support might be available 24/7 on-site for several weeks. For a smaller departmental system, it might just be enhanced help desk support for a few days.
And what about user feedback during that initial period? They must be finding things they don't like or things that aren't working quite right.
Oh, absolutely. The feedback floodgates open. But here's a key piece of advice that experienced project managers always give. Resist the urge to make immediate changes based on every initial user suggestion or complaint.
Why is that? If something's wrong, shouldn't they fix it?
Well, critical issues impacting patient safety or core functionality, of course, must be prioritized and addressed immediately through the established issue management process. But many initial suggestions or complaints stem simply from unfamiliarity with the new system and changed workflows rather than actual system flaws. Users are learning, they're adapting, their muscle memory is fighting them. Making rapid-fire changes based on this initial, often emotional feedback can lead to instability or introduce new problems.
So give it time to settle.
Exactly. It's better to document all non-critical suggestions, provide reassurance and continued support, and then evaluate those suggestions more formally maybe a month or two after activation. By then, users are more accustomed to the system, and you can better determine if the requested change reflects a genuine need for improvement or was just part of the initial learning curve. prioritize stability in those early days.
That makes sense. Manage the critical fires, but let the dust settle on the smaller stuff. Okay, so the system is live, stabilized, users are getting accustomed to it. But the work isn't over, is it? We now shift into the final phase we wanted to discuss. Phase 3, support and maintenance. This is the long haul, right? How do organizations keep these complex, vital systems running smoothly and effectively over time, ensuring they continue to deliver value years after the go-live party?
Exactly. The project might be officially closed out, but the system now transitions into operations and maintenance mode. This responsibility typically shifts from the temporary project team to the permanent IT department and operational owners. Their focus is on ensuring the ongoing reliability, stability, performance, and security of the system.
So what does that involve day to day or month to month?
This phase is characterized by several critical ongoing processes. Configuration management is key. How are ongoing changes to the system's setup made, tested, and approved? You can't just have analysts making changes on the fly in the live environment.
Need that same discipline as during the project.
Even more so, arguably. Then there's release management. Vendors regularly release updates, patches, new versions. Organizations need a process for evaluating these releases, deciding which ones to implement, scheduling the updates, testing them thoroughly, and deploying them, usually during planned downtimes. And, of course, there's ongoing customer support. This is typically handled via a tiered service desk or help desk, where users can report problems, ask questions, or request assistance. Clear processes for logging, prioritizing, resolving, and escalating issues are essential.
What about documentation? Does that get kept up to date?
It's crucial that it does, though it's often a challenge. Effective long-term operations rely on comprehensive, current documentation. This includes communication plans, who needs to know about downtimes or major changes, service desk knowledge bases, so support staff can resolve common issues quickly, technical documentation like data flow diagrams, and updated workflow documents reflecting how the system is actually used in practice.
So it's all about controlled, managed change and reliable support.
Precisely. The mantra is controlled change. Whether it's a vendor update or an internal configuration request, changes typically move through distinct environments, from a development environment to a testing or quality assurance environment, and only then into the live production environment after rigorous testing. A key part of that testing is regression testing, ensuring that the new change or update hasn't inadvertently broken some other piece of existing functionality that was working perfectly fine before. Catching those unintended consequences before they hit the live system is vital.
Okay, so they're managing changes, updates, support. How do they step back and evaluate if the system is truly performing as expected over the long term? Is it actually meeting those original goals identified way back before selection? Is it delivering the anticipated return on investment, ROI?
That's a really important question, and one that sometimes gets overlooked once the initial go-live pressures ease. Analyzing data for problems and trends and assessing performance against goals is essential for continuous improvement and demonstrating ongoing value, particularly within the first year post-activation. It's crucial to formally assess whether the system met the original need identified prior to its purchase. Did it solve the problem it was supposed to solve? And did it achieve the expected return on investment, whether that was financial savings, efficiency gains, quality improvements, or enhanced patient safety?
Who do they report that back to?
These findings should ideally be reported back to the governance committee that initially approved the project. It closes the loop and provides accountability for the significant investment made.
How do they collect the data for this kind of evaluation?
There are various methods. User satisfaction surveys can gauge perceptions. User groups or focus groups can provide qualitative feedback on usability and workflow fit. Analyzing error reports and help desk logs can identify recurring technical problems or areas where users are struggling. Monitoring system performance metrics like response times, uptime is also important. All this data helps identify trends in user adoption, satisfaction, system performance, or potential areas needing optimization or further training. It enables that cycle of continuous improvement.
So it's not just set it and forget it. It requires ongoing attention and analysis.
Definitely not. These systems evolve, healthcare needs evolve, technology evolves. Ongoing assessment is key to ensuring the system remains aligned and effective.
Now let's talk about the big what-ifs. Every hospital leader, every IT director surely dreads the call. The system is down. In healthcare, this isn't just an inconvenience like your email being down. It can be a genuine patient safety crisis if doctors can't access records or place orders. How do healthcare organizations prepare for that kind of critical disruption? What's the safety net?
You're absolutely right. System downtime in healthcare is incredibly serious. And this raises that crucial question for every organization. How prepared are you for the unexpected? And how will your critical functions continue to operate when the primary system is unavailable? This is where business continuity plans, BCP, and disaster recovery plans, DRP, become absolutely paramount.
BCP and DRP, are they the same thing?
They are distinct but closely related and often discussed together. The Business Continuity Plan, BCP, focuses on the business or operational side. It answers the question, how do we continue to care for patients and run essential operations without the system?
So manual processes.
Essentially, yes. The BCP outlines specific manual procedures, often involving hard copy paper forms for things like medication administration records, physician orders, nursing documentation. It details how staff will access essential information, maybe from read-only backup systems or printed reports, how communication will work, and crucially, how data recorded manually during the downtime will eventually be entered back into the system once it's available again, often called recovery procedures. It's about maintaining critical patient care and operational functions using predefined workarounds.
Okay, so BCP is about keeping the operations running manually. What's the DRP then?
The Disaster Recovery Plan, DRP, focuses on the technical recovery of the system itself. It answers the question, how do we get the system back up and running as quickly and safely as possible after an outage?
What goes into a DRP?
Key technical elements. Things like regular, verified data backups, often nightly, sometimes more frequently for critical data with copies stored securely off-site in case the main data center is affected by fire, flood, or other disaster. Having redundant hardware duplicate servers, network components potentially at a separate physical location. Implementing technologies like automatic failover, where a backup system takes over almost instantly if the primary system fails. The DRP outlines the precise step-by-step procedures for technical staff to identify the cause of the outage, resolve the issue, whether it's hardware failure, software corruption, cyber attack, etc., restore data from backups if necessary, and bring the system back online. It defines recovery time objectives, RTOs, how quickly must it be back, and recovery point objectives, RPOs, how much data loss is acceptable.
So BCP is the manual workaround, DRP is the technical fix.
Exactly. And both plans are useless if they just sit on a shelf. They absolutely must be tested regularly. Organizations conduct planned downtime drills, tabletop exercises walking through scenarios, and technical failover tests to ensure the plans actually work and that staff know their roles during a real event. Clear, predefined communication plans for downtime events are also essential. How are staff notified? How are updates provided? Who makes the call to initiate BCP procedures? Preparation and practice are key to managing these high-stress events effectively.
Wow. Preparing for the worst really is a critical part of managing these systems long term. What an incredible journey we've just taken, really, from that very first spark of identifying an organizational need, through the rigorous selection process, the massive effort of implementation, and now into the complexities of ongoing support, maintenance, and disaster preparedness. It's crystal clear that bringing a major healthcare IT system to life and ensuring its continued value and safety is truly a marathon, not a sprint. It's really a testament to organizational discipline and planning.
Absolutely. This whole life cycle really exemplifies how incredibly detailed planning, a systematic, phased approach, constant communication, user engagement, and ongoing vigilance are utterly essential for the effective selection, implementation, and utilization of these complex systems. And ultimately, all of this effort is directed towards ensuring the highest quality and safety of patient care, all while meticulously aligning with the organization's strategic direction and its stringent privacy and security requirements. Knowledge is most valuable when it's understood and applied, and this entire process, selection, implementation, maintenance, is a powerful testament to that principle in action.
So, what does this all mean for you listening in? Well, the next time you interact with a healthcare provider, maybe you're checking in at the front desk, or your doctor is reviewing your history on a screen, or you're getting test results through a patient portal. Take just a moment to remember the intricate dance of technology, process, and human effort happening constantly behind the scenes. It's this complex ecosystem built through phases like the ones we've discussed that's designed to ensure your information is secure, accurate, accessible to those who need it, and ultimately supports the best, safest possible care. And remember, this isn't a static achievement. It's a continuous evolution, always adapting to new needs, new regulations, new technologies, and new challenges. It makes you think, doesn't it, about the layers upon layers of planning, execution, and ongoing effort that go into almost every technological leap we rely on in our daily lives, especially in critical sectors like healthcare. Reflecting on this whole life cycle we've walked through, from that initial idea to keeping it running years later, what stands out to YU as the most critical step, or maybe the most challenging phase in this entire journey? Is it getting the selection right, nailing the implementation, or maintaining that long-term vigilance? We hope this deep dive has given you a fresh, maybe even a little overwhelming perspective on the unseen complexities that power our modern healthcare system. There's so much more beneath the surface. Until next time, keep digging, keep questioning, and keep learning.